Welcome to this explainer. Today we're diving straight into the rapid, almost dizzying acceleration of artificial intelligence. We're going to trace its roots all the way from early industrial innovation, right up to the absolute miracles, and frankly, the terrifying existential risks of today. Because really, this is the story of how we stopped just building machines to do our heavy lifting and actually started building minds in our own image.
Here's our roadmap for today. 1. The quest for intelligence. 2. How machines learn to think. 3. AI's miracles in medicine. 4. Deepfakes and the dark side. And finally, 5. The future of civilization.
Section 1. The quest for intelligence, the spark of innovation.
To really get AI, we have to look back at the continuous spark of innovation that brought us to this exact moment. For centuries, our tech was strictly physical. We went from the mechanization of the cotton gin in 1793 to literally mastering the skies in 1903. But then, during World War II, the legendary mathematician Alan Turing started working on code-breaking machines. By 1951, Turing made a wild prediction. He said that by the end of the century, computers would converse so well you wouldn't even know if you were talking to a human or a machine. That bold idea set the stage for the term artificial intelligence being coined at Dartmouth in 1956, and it all snowballed into the massive generative AI boom we're living through right now.
Now, there's been a monumental shift in how these systems actually operate. Classic AI, like IBM's Deep Blue, which famously defeated chess champion Garry Kasparov in 1997, relied on massive brute force calculation. It was scanning 200 million chess positions every single second. It was effective, sure, but as the sci-fi writer Arthur C. Clarke once put it, they were essentially just high-speed morons following strict rules. Modern AI? It completely flips the script. Instead of programming rigid rules, we build digital systems that literally mimic the 80 billion interconnected neurons in our own brains. It allows the machine to recognize patterns and, this is key, actually learn from vast oceans of data.
Section 2. How machines learn to think. Catching fire. So, how exactly did we pull this off? How did we teach machines to think instead of just calculate? Well, it all comes down to the neural network. Modern AI relies heavily on this concept, which quite literally mirrors the biological wiring inside our heads. It processes inputs through interconnected nodes, basically digital neurons, and passes outputs along. And just like us, it learns by adjusting the strength of the connections between those nodes based on experience.
Think of it kind of like training a puppy. The AI takes in a massive amount of data, maybe millions of cat photos or countless hours of video game footage, and it makes a prediction. When it gets it right, it gets a digital reward, which strengthens those neural connections. When it gets it wrong, it gets a punishment. Then, it uses this brilliant mathematical process called backpropagation to send that error backward through the network to update its weights. It literally rewires itself to get smarter for next time.
And this brings us to a massive turning point. DeepMind built an AI called AlphaGo to play the ancient, insanely complex board game Go, right? It played against itself millions of times using this reinforcement learning. Cut to 2016, it's facing a human grandmaster, and it makes a move so novel, so completely unexpected, that experts watching literally thought it was a computer glitch. But it wasn't. It was a stroke of absolute genius. The AI exhibited emergent creative behavior. It was doing things we never specifically taught it to do. It was thinking outside the box.
Section 3. AI's miracles in medicine, the light.
Let's look at how this translates into the real world, because this tech is rapidly becoming a Promethean light, solving some of our greatest physical limitations. The impact here is nothing short of miraculous. Take AlphaFold. It successfully predicted the 3D structures of 200 million proteins. That's virtually every single protein known to science. It allows researchers to sort for life-saving drugs almost like you'd use an Airbnb filter for a weekend getaway. Then you have deep learning systems like Mirai and Sybil. They are spotting breast and lung cancer from scans up to 5 years before a human doctor could ever detect a lesion. AI is completely shifting medicine from treating advanced diseases to preventing them before they even start. Oh, and out in nature, systems like Alert California are actively scanning thousands of mountaintop cameras, spotting the very first wisps of smoke, and stopping microfires before they can explode into devastating megafires.
AI is even giving us literal physical superpowers. For amputees, bionic limbs are now using machine learning algorithms to decode incredibly faint electrical signals in their remaining muscles. The human and the machine are actually learning and adapting together. And over at MIT, researchers are completely reinventing the autonomous vehicle. Actually, instead of relying on massive, power-hungry data centers, they've built what they call liquid networks.
By studying the highly efficient brain of a microscopic worm, they figured out how to run an autonomous car in brand new environments using a neural network of just 19 neurons. 19! It's incredibly powerful and highly portable.
Section 4. Deepfakes and the dark side. The burn.
But as with any fire, the warmth and light it brings is paired with the terrifying reality that it can easily burn our house down. The exact same tech that's curing diseases has drastically lowered the barrier to manipulating reality itself. Let's look at the two main culprits, GANs and diffusion models. GANs basically pit two algorithms against each other. One generates a fake image, the other critiques it, over and over in this dizzying loop until the fake is totally indistinguishable from reality. Diffusion models, which power most modern image generators, do something even crazier. They take pure visual static and reverse engineer it into a highly realistic masterpiece based on a simple text prompt. Because of these tools, we are plunging headfirst into a world where seeing is no longer believing. Video evidence is just no longer ironclad proof of the truth. And the consequences are painfully real. That massive number, 500 billion, $500 billion. That is the exact amount of value the stock market bled in a matter of minutes back in May of 2023. Why? Because a single AI-generated fake image of a bombing at the Pentagon went viral on social media. It took mere seconds to spread, and the financial impact was immediate and staggering.
Beyond deepfakes and the absolute collapse of a shared reality, we're staring down a slew of near-term complications. We're talking massive job replacement, the supercharging of bias and hate content, and the terrifying reality that generative tools could make it way easier for bad actors to design bioweapons. But perhaps most concerning of the whole shebang is the black box problem. We're building systems so impossibly complex, with billions of parameters, that even the pioneering computer scientists who created them cannot fully audit or understand how the AI is actually making its decisions. Wild, right? This black box reality has led to some deeply chilling statements from the very people building these systems. In 2023, top AI pioneers signed a single-sentence public warning, officially elevating the risk of AI to the level of pandemics and nuclear war. It highlights the so-called Terminator scenario, the very real fear that we're building non-human minds that will eventually become smarter than us, and when they do, we might not even be able to pull the plug.
Section 5. The Future of Civilization. The Masters of the Flame.
So, this brings us to how human civilization handles this double-edged sword and who will ultimately be the masters of the flame. Despite all the existential risks and the loud calls for regulation, there is a commercial freight train driving this forward that is practically unstoppable. AI is projected to have a $13 trillion economic impact by the year 2030. Let that sink in. The commercial incentive for companies, and frankly, entire countries, to win this race means that hitting the brakes is incredibly difficult. And because of this massive, unprecedented investment, AI isn't locked away in pristine university basements anymore. It's right in our pockets. We have an incredibly accessible ecosystem today. Chatbots and AI assistants interact with us through natural, conversational narrative, which is exactly how humans have learned for millennia. They integrate deep research, real-time data, file uploads, personalized plugins. These generative tools are on our laptops and phones, acting as our everyday interfaces for research, creation, and communication. Make no mistake, we are living inside the experiment.
We find ourselves standing at the edge of a completely new epoch. Every major era of technological transformation, from the steam engine to the smartphone, has forced society to completely rethink its values. But we are currently at the precipice of the most profound shift yet. We are actively engineering the future, absolutely. But we are walking down a road to the totally unknown.
As we wrap up this explainer, I want to leave you with one final, vital thought. We have spent centuries dreaming of building machines in our own image. Now that we finally have, who will ultimately be the master? Will these incredibly powerful digital minds serve humanity, or will humanity eventually serve them? Thanks for watching, and keep asking the big questions.